Hi everyone, I'm Jim White. In my first video on Aircrete, I used this as a foam generator. For $1.50, you can generate about a gallon of foam. But this has other additives in it, oils and fragrances and so forth. So I really needed to move on to making real foam. Also, I was only doing very small scale experiments with this, and I plan to now do medium scale stuff. So I've come up with a foam generator that'll suit needs for medium type experiments. And I'll show you how it works. Well, here's the foam generator. It's made out of 2-inch PVC pipe. It holds about a half a gallon of the foam generating liquid. And let's get a little closer here. And because I have shop air here, I wanted the regulator close by, so I built the pressure regulator right into the unit. And there's the fill cap where I pour the liquid into the tank. And this is just air, and this here is the feed for the liquid. So the air comes around here, and this device is an eductor, and that's where the liquid and the air mix, and then goes down the hose to the wand. And I have a air blow-off type valve here to turn the whole thing on and off. So let's have a little demonstration of this next. Okay, in this bucket I had 5 gallons of foam that I left sit overnight. This was made with Dawn dishwashing liquid, and you can see the liquid has separated from the foam. The foam was fine at first, but this has been sitting here for maybe 12 hours. So I'm going to reuse the liquid. I'm going to put it into the foam generator and shoot it through again. Okay, here's the liquid that I drained from the bucket, and we're going to recycle it. I try to pour down the side of the pipe so that I don't generate a bunch of foam in the reservoir tank here. Okay, I'll put the cap on that, and we'll recycle it into foam again. Okay, I'm going to set the pressure to 30 psi. My incoming pressure here is 120 psi. And first thing I do is run it until I start getting some foam. And then I'll start shooting it in the bucket. And you can see it's a very nice thick foam. By the way, this tank only holds enough liquid to fill 2.5 5-gallon buckets. And of course, the liquid that you use would have some effect on that as well. So I'm not into mass production. I'm only going to do reasonably small things. So for me, this is a fine rate of foam. I hope you can see how nice and thick that foam is. And anytime I want to stop, I just let go of the valve. Well, just for fun, let's open our needle valve a little further, and let's crank her up to 50 psi and see what our foam rate is. See, I got a small leak there on the cap on the end of the valve of the wand. So this wand's made with screw-on end caps on each end, and I need to seal this one up a little better. And you see we have a kind of a big hole at this end. I didn't want to shoot foam all over the place. So, and this is packed with steel wool, a very fine stainless steel wool. And I actually have a piece of hardware cloth across the opening. I don't know if I can show you with one hand, but in here is a piece of hardware cloth. There, I can see it a little bit, and that's holding the stainless steel into the unit so it doesn't come on out. So I'd say that's a pretty good production rate of foam. And I don't know what the ultimate limit is, but I don't want to go too fast. Well, you've seen in some of the Aircrete videos done by others, the Suave and the Dawn. And I saw this Pure and Clear in the store, and it has no fragrances or colors, and I thought it might be worth a try. So when I've made foam with any of these, I've used a mix ratio of 35 parts water to 1 part of the detergent. So I'm going to shoot a mix of Pure and Clear now and see what that foam looks like. Okay, here we go with the Pure and Clear. It looks pretty much like the others. Well, no, it looks like it's collapsing pretty fast, however. The stuff I shot in the sink at the beginning is already disappearing rapidly. And the texture of this is changing quickly. So I don't think this is a good alternative at all. Here's the Drexel FM 160 that's recommended by a lot of people. I took the label off of the one bottle because all the safety warnings and mixing instructions are in there. So next we got to figure out how much of this to mix up. The Dawn and Suave were mixed with water at a 1:35 ratio by volume. That's 1 fluid ounce of the detergent to 35 ounces of water. The ratio recommended for the Drexel is 160 to 1. So to mix up, that would be like 1 gallon of Drexel to 160 gallons of water. For a small batch, let's say we wanted to mix up 1 gallon of solution. So into 1 gallon of water, we would need to add only 0.8 fluid ounces of Drexel. And that's a very small volume, and I really don't have anything to measure that with. So I'll convert it to milliliters. And so the 0.8 fluid ounces is 23.7 milliliters. So it turns out I did have a graduated cylinder here that's marked off in milliliters. The top of the scale is 25 milliliters, and I don't think you can see that, so I marked the amount that we need with the little black line there. So I'm going to fill that up to that line, and then we're going to mix it with a gallon of water. Okay, I've poured about a half a gallon of water into this bucket here, and I'm going to pour in the solution. We see that it's not thick at all. It's very watery. So because it's such a low amount, I'm going to actually submerge it in here to make sure we wash out the inside of the cylinder and get all of it into the water. And then I'm going to add the rest of the gallon and then put some of it into the foam generator and see how it works. Okay, I've filled our foam generator with the Drexel solution, and we'll crank her up to 30 psi. Okay. It's a nice, thick, good-looking foam so far. I'm going to crank the pressure up to 50 so we can produce it a little faster. Okay, that's pretty good looking foam. It looks very good. I'm going to go ahead and see how many buckets I can get out of this batch. Well, I only got a bucket and a half out of this batch, but I might have had my mixture set too rich. I'm not sure. But the foam is holding up, and if what everybody else says is correct, this should be a far superior foam. And we have probably a lot to learn about the mixing ratio and so forth. And we can experiment with that in the future. But this was an incredibly small amount of the Drexel solution. So I'll do some more experiments in the future, and we'll carry on now with the video and get into some more technical details. Okay, don't forget this reservoir here only holds a little less than half a gallon of solution. Okay, I know a company called Rural King carries the Drexel. So that's ruralking.com. And then here we'll enter the Drexel. And you can see some other things here that Drexel makes. But we need to enter the FM 160. Okay, here it is. $17.99 per gallon. And you can have it shipped to you or have it shipped to the store. Apparently they don't normally carry it in the store. So I ordered 2 gallons and the shipping came to $7.93 for the 2 gallons. So there is a store within 20 miles of me. Perhaps they ship it to the store and that's the shipping charge from the store. I don't know. But I think that's a very reasonable price for something that works quite well. Well, it's a lot of fun mixing up chemicals and shooting foam all over the place and mixing cement and water and so forth. I really like it. But we have to get serious at some point. And the first thing we got to talk about is weights and measures. If we're going to do things accurately so that any strength testing we do later will have meaning. So we're going to be dealing a lot with gallons. And the definition of the United States gallon is that it's 231 cubic inches, which is 128 fluid ounces, which is 3.79 liters. Now that's a measure of volume and not weight. 128 fluid ounces of water weighs 133 ounces of weight. That's ounces avoirdupois. But 128 fluid ounces of sand, remember this is a volume measurement, could weigh a lot more than that. And when we're using soaps and other liquids to make our foam, we're usually dealing in fluid ounces. And a heavy shampoo, you notice when you pour it into the water, it sinks rapidly. That can be a lot heavier than 133 ounces of water. So we got to be aware of the difference between volume and weight. This only applies to a gallon of water. A gallon of water only weighs 834 pounds. I'm sorry, 8.34 pounds, or 3.79 kilograms. And notice those two are the same. But a gallon of sand could weigh much more than that. Now let's look at the volume of things again. We have other breakdowns of a gallon. A gallon can be 4 quarts, or 8 pints, or 16 cups, but it's always the 128 fluid ounces. A quart is a quarter of a gallon, 32 ounces, fluid ounces. A pint's 16, and a cup is 8. So we did an experiment with making 2 cups of cement water mixture, and we're going to use the results of that to calculate the final volume you could get with a 94-pound bag, 6-gallon mix of our Crete solution. Okay, here's the container that I mixed 1 pound of cement powder to 0.53 pounds of water. Now when I put the powder in here, I was almost up to the 2-cup line. And after adding the water, the volume had increased just so slightly. And so I think you can see where there's a little separation line with the stuff that got smeared on the side. So at any rate, that line right there is at the 2-cup line. Well, just below it. And over here, that's almost 450 milliliters for the metric measurement. So that's the volume that you get from mixing 1 pound of concrete with 0.53 pounds of water. The starting mix that I see everybody using on the Aircrete videos is a 94 bag of Portland cement to 6 gallons of water. Now that's 50.1 pounds of water. So the total weight of the mix would be 144.1 pounds. Now when we mixed 1 pound of cement with 0.53 pounds of water, we got 2 cups. So that's saying for each pound of cement, we're going to get 2 cups by volume. So 2 cups per pound times 94 pounds is 188 cups of volume. And 188 cups at 16 cups per gallon is 11.77 gallons. And a cubic foot contains 7.48 gallons. So that works out to 1.57 cubic feet for a full mix. So now this might not be an ideal mix, however. It turns out the more water you use with concrete, the weaker it is. So not only do we have a pretty soupy mixture here to begin with, we're also going to add more water because there's water in the foam. So there might be ways to use less water and end up with a stronger product. So next I'll show you roughly what a 1.5 cubic feet looks like. This box, this cardboard box, is 1.5 cubic feet inside measurement. So the outside is a little bit more than 1.5 cubic feet. Now for size comparison, let's say 500 milliliter bottle of water on the right, and that's a gallon jug of water on the left. So this should give you a rough feel for how much product we get by mixing 94 pounds of cement with 6 gallons of water. And of course, as we add foam, we would get more than that. In order to test the concrete strength or the aircrete strength, we need to have some kind of a uniform sample to use each time. And I got the idea of making muffins of aircrete, and what I did was spray the pan with one of these cooking release agents. There's various brands available, and after pouring the mixture in and screeding it off smooth and flat, then I covered it with this plastic wrap in order to keep the moisture from evaporating. You want the moisture to stay in and react with the components in the cement. So this is an experiment. This is my very first pour. I just want to see if these things will come out of here. How about that? Okay, there's muffins. Now this was just a cement water mixture with no air. But what we will do next, in another video, I have to build a press for seeing how much pressure on these they can withstand before crumbling. And then we can rate each batch of aircrete and with various other constituents, perhaps sand and things like that, to see what the best aircrete is. For those of you who might be wondering why the Drexel foam generating solution exists and why it's sold through farm outlets, here's an Apache sprayer website. And here we see a sprayer leaving a trail of globs of foam while spraying. And in this way, they can see where they've sprayed and line up their return paths across the field. So that's what the Drexel FM 160 is normally used for. I just learned that the 160:1 mix ratio that's recommended by Drexel is based on the farm type usage of it. When they use it to mark a path in the field, they want it heavy enough that it doesn't blow away, and they don't want it to last all day. So it turns out by using a lower mix ratio, you get a lighter foam and more of it. And so by increasing the amount of the FM 160 in your solution, you actually get more foam. So it's not like it's going to waste by using more. So in the future, I'm going to try out a mix of 1.2 fluid ounces per gallon of water. And so that's another area of experimentation that needs to be done to find that ultimate mix ratio. Here's a tabletop hydraulic press that I built about 20 years ago for some quick experiment. And I think I can use this. And we'll put the muffins of Aircrete between something that we'll arrange here and see what it takes to crush them. Now this is a hydraulic ram. This piston can move here about an inch, and I got a 0 to 1000 psi gauge and a 0 to 5000 psi gauge. So the idea here is we'll have the gauge connected to the ram, and I'll have a check valve in here and a bypass valve. And as the cylinder is pushed down, pressure will increase and the gauge will read. The check valve will keep the needle where it is after the sample crumbles. And so we'll have a peak reading load cell. And the gauge that I use will depend on how strong Aircrete turns out to be. So that'll be the build of this load cell, and the press arrangement will be the subject of another video. So stay tuned for that. Subscribe so you don't miss it. See you later.